The arc extinguishing chamber is the core component of the sulfur hexafluoride circuit breaker. Its performance determines the breaking capacity of the sulfur hexafluoride circuit breaker. Today, we will learn about the arc extinguishing chamber of the sulfur hexafluoride circuit breaker. First, let's understand the types of arc extinguishing chambers. According to the different structures of the arc extinguishing chamber, it can be divided into two types, double pressure type and single pressure type. The double pressure type has two pressure systems. One is a 0.3 to 0.6 megapascal pressure system, mainly used for internal insulation. The other is a high pressure system with a pressure between 1.4 to 1.6 megapascal, used for arc extinguishing. The double pressure sulfur hexafluoride circuit breaker has excellent arc extinguishing capabilities, but its structure is complex with many auxiliary devices. It has gradually been phased out. The single pressure type has only one pressure inside. It relies on gas compression to achieve arc extinguishing. According to the different structures of the arc extinguishing chamber, it can be divided into variable gap arc extinguishing chamber and fixed gap arc extinguishing chamber. According to the different sources of arc extinguishing energy, there are external energy type and self-energy type. The external energy arc extinguishing device uses external stored sulfur hexafluoride gas or operating force to move the sulfur hexafluoride gas, thereby extinguishing the arc. The external energy arc extinguishing device is suitable for extinguishing small currents because the energy of small current arcs is not enough to drive the flow of sulfur hexafluoride gas. The self-energy type is developed on the basis of the single pressure type. It uses the energy of the arc itself to heat the sulfur hexafluoride gas in the cylinder, creating the pressure difference needed for arc extinguishing. It increases the arc blowing pressure at the current zero crossing while ensuring the breaking capacity and minimizes the operating power required for the product, reducing the burden on the operating mechanism. Next, we will introduce the variable gap arc extinguishing chamber and a fixed gap arc extinguishing chamber and a fixed gap arc extinguishing chamber. The single pressure type, also known as the compressed gas type, has a movable part with a compression device, mainly used in voltage levels about 252 kilovolt. According to the different structures of the arc extinguishing chamber, it can be divided into variable gap arc extinguishing chamber and fixed gap arc extinguishing chamber. According to the arc blowing method, it can be divided into one-way arc blowing and two-way arc blowing. The variable gap arc extinguishing chamber has a contact gap that continuously changes throughout the opening process. The arc blowing methods are one-way longitudinal blowing and two-way longitudinal blowing. The former is suitable for small capacity circuit breakers. The latter is suitable for high voltage large capacity circuit breakers. The structure of the variable gap arc extinguishing chamber is as known in the figure. Mainly consists of the contact system, compression cylinder, check valve, compression chamber, and fixed piston. The contact system includes working contacts, arc contacts, and intermediate contacts. The function of the check valve is to ensure that during the opening process, the gas in the compression chamber is concentrated to blow the arc towards the nozzle. During the closing process, the gas chamber opens, allowing external sulfur hexafluoride to smoothly enter the compression chamber, preventing a vacuum from forming in the compression chamber. Its opening principle is as follows. When the arc extinguishing chamber opens, the operating mechanism moves the moving contact, arc contact, insulating nozzle, and a compression cylinder through the pull rod, creating pressure between the pressure piston and the compression cylinder. When the moving and stationary contacts separate, an arc forms between the contacts. At the same time, the sulfur hexafluoride gas in the compression cylinder under pressure is expelled from the nozzle at high speed, acting on the arc, extinguishing it. During the closing operation, the sulfur hexafluoride gas in the arc extinguishing chamber through the check valve quickly replenishes the cylinder, preparing for the next opening. The advantages of this arc extinguishing chamber are that the gas blowing time is sufficient, the gas utilization rate is high, and the breaking capacity is high. However, due to the large contact gap, the arc is long, the arc voltage is high, and the arc energy is large, which is not conducive to increasing the breaking current of the circuit breaker. In addition, the insulating nozzle is easily burned by the arc, which affects the dielectric strength of the arc gap. The fixed gap arc extinguishing chamber has two stationary contacts that always maintain a fixed gap. The airflow blows the arc towards the nozzle of the stationary contact with symmetrical two-way longitudinal blowing. Its structure is as shown in the figure, mainly consists of the contact, compression device, and pull rod. The contacts of the circuit breaker are composed of two hollow stationary contacts with nozzle 3 and 5, and a moving contact 2. When closing, the moving contact 2 bridges between the stationary contacts 3 and 5, forming the current path. When opening, the arc gap of the circuit breaker is maintained at a fixed gap by the two stationary contacts. The compression device includes a compression chamber, compression cover, fixed piston, etc., which is an important device for forming compressed gas. Its operating principle is as follows. During the opening process of the arc extinguishing chamber, the gas cylinder is moved by the moving contact rod, compressing the sulfur hexafluoride gas in the compression cylinder, creating high pressure. When the moving contact rod moves to the nozzle and opens it, the high-pressure sulfur hexafluoride gas in the cylinder is expelled from the nozzle, blowing the arc, extinguishing it. Throughout the process, its arc-blowing energy comes from the operating mechanism. The characteristics of this arc extinguishing chamber are that the electric field of the breaking gap is uniform. The arc extinguishing gap is small. To the arc extinguishing position is very short. The arc energy is small. The arc extinguishing capability is strong. However, the volume of the compression chamber is large. Well, that concludes today's content. Thank you, everyone.